In this video, we will see how to segment and extract shape from satellite image using Google Colab. Let's get into it. In this video, we will try to extract the lake shape boundary using segmentation of satellite image. Of course, we can digitize the shape using the base map. For that, we need to go to layer, create a new layer. Let's make it a polygon and let's make a shape. Now we can digitize manually, but it needs a lot of effort. Let's try to do it automatically by segmentation of this image. For segmentation of satellite image, we will use Google Colab. I will share this notebook with you so that you can easily run the course from the notebook. First, we need to install some dependencies. We will use Segment Geospatial, Grounding DinoPy, Leaf Map, a local tile server. The codes are taken from QGIS Segment Geospatial website, who developed this SamGeo package. To install the dependencies, we need to use the GPU runtime. For that, we need to click on runtime and click on change runtime type and select T4 GPU and save. Now let's connect to the runtime. Now we need to install these packages. It will take some time, so keep patience. Let's run the code. The libraries are installed now. It took almost 5 to 6 minutes. Let's clear the output. Now we need to import the libraries. First, we will import leaf map, which will let us show our images in the interactive map. And from SamGeo, import TMS to GeoTIFF. That means tiled map service to GeoTIFF, where we can use any map service and convert the selected region to GeoTIFF. And the next one is samgeo.textsum import langsum. This langsum module will let us detect any specific object in the image. That means we will detect the lake in this case. Let's import all these libraries. Since the library and modules are bigger, so it will take some time. The process is done. Now let's create an interactive map where we can select our area of interest. For that, we will create a map named M. M is the variable. M equals leafmap.map. And we will center it to a location. Then we can change interactively. And zoom level, here it is 19. The more the zoom, the bigger the pixels are. Let's reduce the zoom level to 14 or something. And this is the height of the map. And the map should have a base map. Here we will use the satellite image. From this satellite image, we will select our area of interest and save it to as GeoTIFF and segment our desired object there. Now let's see the map. Here we can see the map. Let's zoom out and select a lake. Let's select this lake for detection purpose. Now we can make a rectangle. Click on the rectangle and select the area that we want to detect. Now our area is selected. We will save this image to GeoTIFF. For that, we will use this bounding box. The bounding box will get the area from this bounding box that we have drawn here. And if we do not have any bounding box, then there is a default bounding box. Since we have drawn our own bounding box, this will not make any difference. Then we will save the image to a variable that is image, and this image will be converted to GeoTIFF from tiled map service to GeoTIFF. Here output we pass our image variable, and bounding box is this bounding box. That means our drawn bounding box here. And zoom level, let's make it 10 or maybe 11, because if we make it 18, 19, then the image will be much bigger, which will be critical to handle. And for this purpose we do not need that much precise pixels. And source is satellite image. That means here we can see the image, and overwrite is true. That means if there is any image in the same name, then the file will be overwritten. And also, if we do not want to use this tiled map service, if we have our own image, we can use our own image. Here we can pass the location of our image in a variable, then we can detect the objects in our local image. But since in this tutorial we are using the image from this tiled map service, so it will be easier for you to get anywhere in the world and detect any object. Now let's run this and also save the image. You can see that there are 77 tiles of this image, and all images have been downloaded and mosaiced together. Let's clear the selected output and see. You can see that the image has been saved here. So it is only 5 megabyte. So the image size is not bigger. But if we use here 19 or something, then the image will be much bigger, much bigger, which will be very difficult to handle. Now we want to display this image to the map. Let's run this code. The first line basically hide the last loaded layer, so that every time we run, the previous layer will be not shown and the new image will be shown. Let's run the code and see. We can see that our image has been loaded here. Here we can zoom and check the accuracy or pixel resolution of the image. But for our purpose, a little bit lower resolution is not a problem. Now let's go to the next part, that is initialize the langsam class. This will let us to write any object name and detect in the image. Let's run the code. The langsam module has been initialized. Now we can use text prompts to detect anything in our imagery. So since in our imagery we will detect the boundary of the lake. So we will write here lake. We can also pass here water body or water, something like that, but let's go with the lake. Let's run the code, and now we will predict the image that we have already downloaded. And text prompt, it will take this lake here, and box threshold and text threshold. If we increase this value, the confidence level will be higher, and if we reduce this, the confidence will be lower. So basically you need to experiment with these values, which one is perfect for you. Around 0.25 works better most of the cases. Let's go with 0.24 and run the cell. Now let's visualize the annotations. The color will be blue and box color will be red, the bounding box. And title, we have written here automatic segmentation of lake. Let's run the code. Here we can see the bounding boxes that has been selected as lake. Now let's show only the boundary of the lake without the bounding box. Here the dark blue part is detected as lake, and some of the area that is shallow water is not detected. Let's see the grayscale image. This will create a Shapefile with only 0 and 1 values, that is a binary image. Let's run the code. You can see that this area has been identified as lake. Now if we want to export this area as a shapefile or GeoPackage file, we can export the shape and then we can download and use in any GIS software like ArcGIS or QGIS. Now let's run the code to export our lake TIFF to convert it to vector, and we will make it as GeoPackage. You can make it a shapefile using SSP, but Shapefile will make several files so that GeoPackage is easy to handle, because GeoPackage will create only one file. You can see that our lake TIFF is saved. Now if you run this, then another file will be saved as lake.geopackage. Here you can see that the geopackage file has been created. Now if we want to add this raster and also the vector, we can add it to the map. Let's run the code. Here our raster file is added, and on top of that raster, the vector file is also added in the leaf map. If we want, we can also segment in the interactive environment. Let's run this. And here you can see the image, and if we write the text prompt here, and we can change the box threshold, text threshold here interactively, and if it is a building shape or something that needs to be regularized or make the square or something shape, then you can use the regularize option. But for this we can just click on segment and it will segment the image if it finds anything that we write in text prompt. Let's segment this. Here we can see that the segmentation task is done. Now if we want to save this segmentation, we can select the save, and here it says no selection. Let's select it and let's name it as Lake 2 and select. Here we can see that the Lake 2 geopackage and Lake 2 TIFF file is saved. So from this interactive menu you can easily segment anything what you want. Now let's download the Lake geopackage file. The file is downloaded in our download folder. Let's bring it to QGIS to see what it looks like. Go to browser, and download folder is saved as our favorite. Now this one is the file that we have downloaded. Let's bring it to the map. Let's zoom to layer and change the symbology. To make it little bit watercolor. Now if we turn off and on, you can see that the shape has been extracted almost accurately, but there may be some sort of distortion which you can manually adjust if you want. Since we are using the Imagery segmentation for the purpose, for most of the cases it works perfectly. Thanks for watching.